Yesterday, you heard about the AOP from several speakers. Dr. Preston introduced it, Dr. McClellan mentioned it, and our distinguished banquet speaker also mentioned it. So I'm not going to repeat here what we have already learned, but what I hope to do is amplify this tool and discuss this tool in more detail and explain why it's worth supporting. In order to do that, I want to go back to one other slide, and that is this slide, which relates more to the theme of the conference. So I think you can see here that one of the key things about risk assessment, one of the key parts of its process, is dose response. And dose response, at least in radiation risk assessment, ionizing radiation risk assessment, is underpinned by the LNT. And it's meant to be protective and conservative, prudent. Recent epidemiology in the low dose range, as we heard here on day one, generally supports LNT, but it's not entirely consistent. And recent radiobiology studies do show variability in response, especially at the molecular, cellular, and tissue levels. And these show nonlinearity in certain circumstances. So the scientific picture is interesting, it's changing, and I think that's really why we're all here, is to try to shed some light on that. Now, to be honest with you, I actually think the question about LNT versus non-LNT is the wrong question. I do agree with the other Paul L. who just spoke, okay? I think that that's the question we shouldn't be dwelling on, but instead we should be discussing about how we're going to integrate all of this really elegant science to move forward as a community. And that's what I want to talk about now, and that's why I think the AOP risk assessment process is so important. So AOP, Adverse Outcome Pathway Risk Assessment, is a way of thinking about biological systems that recognizes their complexity, but also describes some of these things along a key event pathway. Now, as you heard, each event is necessary but not sufficient in and of itself to advance from IR exposure to disease. Now, obviously, this process is, in fact, a series of interrelated events. It's probably not linear, although we're going to model it as linear because we kind of have to start somewhere. And as we learn more about these pathways, we can get more elegant in our description of them. So one of the major advantages of low-dose ionizing radiation is that it gets us much closer to systems biology. And systems biology should be the key integrating philosophy that we have. So this is a paper that I wrote with some other speakers, including a couple of the chairs of this meeting, so it must be right, correct? And in this paper, what we try to do is point out that if you are going to be able to think in things in systems biology, you're going to be able to integrate radiation epidemiology and radiobiology. And that's really important not only for science, but also for underlying laws and policies. 2 minutes? I thought I had 20 minutes. I used to, okay. All right. So this is a concept that was borrowed from toxicology. Time goes much faster in eastern Washington than it does on the East Coast. I think what I'm going to do is just really kind of skip to my recommendations. So first of all, I do think we need more research on low-dose ionizing radiation. We need more basic discovery research. That's not a new concept. We've talked about that. But we also need more applied research. We have to show that the AOP risk assessment pathway is the right way to go. We have to do case studies of this, and we have to show that it can be useful for decision making. So we have to demonstrate that it's better than traditional risk assessment. If we don't do that, we're not going to be able to move to a new paradigm and a new way of combining and integrating all of the great information we have. Second, I think we really need to think about regulatory acceptance. That hasn't been talked about, but let's face it, you can't just write elegant papers about AOP risk assessment and publish them and then expect agencies to use them. You have to show that it's a process that meets the agency's needs under the laws, that meets their mission, and is going to be something that they find useful for decision making. So we all have to focus on how we're going to get this regulatorily accepted. All right, so let me just conclude really quickly. we have some opportunities here. I think the major opportunity we have is to begin to do a much better job of incorporating low-dose ionizing radiation information into the development of laws, regulations, and policies. I think this means we have to expand and evolve traditional risk assessment to AOP risk assessment. And I started this talk by saying that traditional risk assessment was a shotgun wedding between science and law. Why not try to make AOP risk assessment the love child of radiobiology and radiation epidemiology? And if that doesn't keep you up at night, I don't know what will, okay?